Okay, so today we're going to do Chapter 4, Section 6, which is Triangles Congruence by ASA, AAS, and HL. So we've done two other ones before. Do you guys remember? SSS and SAS. So we're just adding three more to that list now. So an included side is the common side of two consecutive angles. Yes. So an included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. So here we have side PQ, this green side, is the included side between angle P and angle Q. So everybody sees how that side is in the middle of angle P and angle Q. So it's the included side. So we have the angle congruence postulate. So this is ASA. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So this we have an angle, a side that is in between the two angles, and another angle. So that side has to be included, which is in between the two angles. So this is ASA congruence. Let's look at an example.
There's no points listed. There's no angles named on it.
That's fine. So example 1 says, determine if you can use ASA to prove the triangle congruent. Explain. So just looking at this, we have two pairs of congruent angles. What else do we know is congruent?
The sides.
Which side?
The one on the right and the one on the left.
How do we know that those two are congruent?
I was just thinking just the lines because they're both two on the right, two on the left.
But there's nothing here that says specifically that those two lines are congruent. Do we know of anything that's congruent from these two triangles?
You mean the middle?
The middle one. We know that this middle line's congruent because of the reflexive property. Yes, you are. Can we use angle, side, angle here in this example? So we have an angle here, and a side here. Is that side in between those two angles?
Yes.
Yes.
Is it the included side in between those two angles?
Don't they share it? So
The included side would be this one here, right? Because that one is in between those two angles. We're just looking at one triangle. So the included side would be this left side and this triangle number 1 here. But this side isn't included, so this blue side isn't included in between those two angles. So in this example, we cannot use ASA to prove that the triangle is congruent.
why?
Because that side isn't included in between those two angles.
Yeah.
So example 2 says, determine if you can use ASA to prove triangle NKL is congruent to triangle LMN. Explain. So looking at this example here, what do we have that's congruent? Okay, Ryan says the line going across, this diagonal one.
Yeah.
Perfect. We know that that's congruent by the reflexive property because it's the same line. We don't know that KL is congruent to NM because these arrows show that these two are parallel, not congruent. So we know that they're parallel. We don't know if they're congruent, but if we have two parallel lines here, two parallel lines, and they're cut by a transversal, we have a pair of alternate interior angles here, and we know that those two angles are congruent.
So wait, how is it yes?
We haven't said yes or no
Oh.
yet. We're just trying to figure out what pairs of things we have that are congruent. So right now we have one angle, one pair of angles, and one pair of sides. Is there anything else we can tell that's congruent here?
The sides.
KN and LN.
We don't know if those are congruent,
So then no.
so no. So all we have here is an angle and a side. So can we use ASA?
No.
No.
Because we only have an angle on the side.
Mm-hmm. What if this was given that this angle here is congruent to this angle here? Then could we use?
Then yes.
Yes, then we can use ASA. Okay, next we have the AAS congruent. So angle side congruence theorem states that if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So here we have an angle.
What's the difference between non-included and included?
Remember, included is in between the two angles. So if we're looking at this triangle, we have two angles here. The included side would be this one. The non-included side could either be this or the other side.
Because it's not.
Because it's not in between those two angles.
But how do you know which line, like how do you know which angle it would be?
The angles that are congruent to the other angles. So here we have angle G is congruent to angle K, and angle J is congruent to angle M. So we're talking about these
okay.
two angles, the two angles with the blue
Right.
highlights.
Mm-hmm.
So a non-included side would be side JH. And then here we have the same angle K and angle M with a non-included side LM. So by the angle side congruence, these two triangles are congruent. Okay, let's look at example 3. Use AAS to prove the triangles are congruent. It's given that angle X is congruent to angle V. So we have X is congruent to V. And we're going to put arc marks there. We have angle YZW is congruent to angle YWZ. So this angle is congruent to this one. And segment XY is congruent to segment VY. So we have this segment is congruent to this one. Can we prove that triangle XYZ is congruent to triangle VYW? How? Because right now, just looking at these two triangles, we have a pair of congruent angles and a pair of congruent sides. What else can we conclude from the information that was given to us?
Which one is the congruent side?
The one with the tick marks.
Oh. And then the angles are one with the arc marks.
Yep.
Okay.
So what else can we conclude from this?
We have two angles that are congruent because of X and B, and then the Y, Z, W. Oh, because of the reflexive property.
If these two angles here add up to 180, and these two angles here add up to 180, and this angle is the same thing as this angle, wouldn't this angle be the same as this one?
Yes.
Yes.
Oh.
So now we have a pair of angles, another pair of angles, and a pair of sides. So can we use angle, side to prove that these triangles are congruent?
Yes.
So
Yes.
How did you figure out the second pair of angles that were congruent?
Because these, so angle XZY forms a linear pair with angle YZW, and angle YWV forms a linear pair with YWZ, and these two we were already told, so this one, this angle and this angle, we were already told that those were congruent. So therefore we know that their linear pairs are also going to be congruent to each other. Any questions? Okay, example 4. Use angle, side to prove the triangles are congruent. We're given that JL bisects angle KLM. So just with that information, that JL bisects angle KLM, what do we know from here? What's equal? So this segment is bisecting this angle.
They're congruent.
What's congruent?
Angle JML and angle JKL.
So we have a segment that's bisecting an angle. So it's cutting that angle in half. So when you cut something in half, we have two equal parts. So
It's the two lines.
if I'm cutting an angle in half, I have two equal angles, right? So the sides wouldn't be equal, it's the angles that are equal. So we have this angle, KLJ, is equal to angle JLM. And it's also given that angle K is congruent to angle M, and they already put the arc marks there for us. What else do we know from here? That's all we were given, but what else can we conclude? Nope.
I don't know, they equal to something.
We have another pair of congruent sides, but which sides are they? JL. JL is congruent to JL. Why?
That's right.
Because reflection property.
Because the reflexive property, yes. So we have an angle, and a side. So can we use AAS to prove that these two triangles are congruent?
Is the side that
Yes.
the reflexive property, is that the side that?
Yes. So we can say JL is congruent to JL because of the reflexive property. So that's angle, side. Now we have one last thing. Can you guys tell me the parts of a right triangle?
The lines, the angle, the 90 degrees.
What are the lines called?
Hypotenuse.
The hypotenuse.
Base.
So this line here is the hypotenuse. It's the base, but what's another name for the base? What can we call these two lines? This one and this one.
Angle.
I forgot. I learned this.
Second hypotenuse.
No.
Second.
No.
Hypotenuse.
They're the legs.
I think legs.
So remember, the side opposite from the right angle is the hypotenuse, and then the other two sides are the legs. Okay, so our last theorem we're going to look at is the hypotenuse leg congruence theorem. It states that if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So we need the hypotenuse and a leg of a right triangle. So here we have AC, the hypotenuse of this one is congruent to the hypotenuse FD, and then we have the leg BC is congruent to this leg FE, and they are both right triangles. So these two triangles would be congruent by the HL Congruence Theorem. So example 5 says determine if you can use the HL Congruence Theorem to prove the triangles are congruent. If not, tell what else you need to know. So let's look at A first. It tells us that we have a pair of congruent sides and we have one triangle with a right angle. What else can we conclude from this? The other triangles are right angled too, because this is a linear pair. So if we have one that's perpendicular, they both are. What else do we know from this?
The hypotenuse is the same as the
Yes.
government.
So if we're using the hypotenuse leg, what else do we need? We have a pair of hypotenuse, we have two right triangles. Kevin.
You're sharing this, the line in the middle.
They're sharing the line in the middle.
Oh.
How do we know that they share that line? How do we know those two lines are congruent? Reflexive. It's the same line, so they're equal. So can we use HL here?
Yes.
Yes, we have a leg, which is this line in the middle, and then we have the pair of hypotenuse. So yes, we can use HL. Let's look at B. So we have a pair of congruent legs, and we know that these are both right triangles. What else can we tell from this picture?
Their legs are congruent.
Yes, they already put the tick marks there for us.
The angle.
The angles, the two right angles. Yep.
The line at the top and bottom,
How do you know?
because the other two lines are congruent.
It's a square.
But we don't know that it's a square.
It's a trapezoid.
Just congruent.
That's a
We don't know if those are congruent or not. Can we use HL here?
no.
No.
You don't have enough information.
What else do we need to know in order to use HL here?
The hypotenuse is
We need to know if these hypotenuses are equal. So if it gave us the two tick marks on the hypotenuse of the two triangles, then could we use HL?
yes.
Yes. But if it doesn't give us that, then no, we can't. We don't have enough information to tell that these two triangles are congruent.
Those two marks were there.
If they were there, then yes, then the two triangles would be congruent. Okay, last example. Determine if you can use the HL Congruence Theorem to prove triangle ABC is congruent to triangle DCB. If not, tell what else you need to know. Allie.
Okay, so their hypotenuses are congruent. They both have 90 degrees, but they also share a line with reflexive properties. So yes, we can use HL. 'Cause
Right,
they
so
share
this
that.
line in the middle here is the same on both triangles. So they have a pair of congruent hypotenuses and a pair of congruent legs. So yes, we can use the HL Congruence Theorem. And how do we know that these two legs are congruent? The reflexive property.
What?
The reflexive property.
Oh, reflex. Oh, I heard like something else.
Okay, so that is 4.6.